number 12 in the Chapter 8 recitation worksheet. So we're going to draw the Lewis structure for each of the molecules or ions and predict their electron domain and molecular geometries. So the first one, we have AsF3. So in this one, the Lewis dot structure is going to look like this. Sorry, my lone pairs are getting a little crazy there. Okay, so remember with the electron domain geometry, we're just looking at, how many things do we have around the central atom? So we've got 1, 2, 3, 4 domains around the central atom. So that's going to be tetrahedral. Okay, and then for the molecular geometry, we're looking at specifically bonding domains and non-bonding domains, which are lone pairs on the central atom. So here we have 3 bonding, 1 non-bonding. So it's going to be trigonal, pyramidal. Okay. And then B, we have CH3 plus. Okay, CH3 plus, so it's going to look like this. And then for our electron domain geometry, we have 3 domains around carbon, our central atom, so it's going to be trigonal planar for our electron domain geometry. And since all 3 domains are bonding domains, the molecular geometry is going to be exactly the same, trigonal planar. Okay, for C, we have BRF3. BRF3. So BR is going to be in the middle, and then we have our fluorines on the outside. Sorry. Okay, and then we put our lone pairs in. So in this one, we're going to have 4 electrons left over after we put our electrons on the outside atom. So we'll have 2 lone pairs on the central atom. So for our electron domain geometry, we have 1, 2, 3, 4, 5 things around, or 5 domains around the central atom. So it's going to be trigonal bipyramidal. And then the molecular geometry, since we have 3 bonding and 2 non-bonding, is going to be T-shaped. So really, that's just a matter of memorizing. For electron domain geometry is how many domains are around the central atom, but then molecular geometry is specifically how many bonding domains and non-bonding domains we have. Okay, and then we have ClO3 negative. So in this one, it's going to look like this. And after we get done putting the electrons around the outside oxygens, we're going to have 2 electrons left over, and those just go onto chlorine. We need our negative. So the electron domain geometry is going to be 1, 2, 3, 4. So we have 4. So that is tetrahedral. And then the molecular geometry, because we have 3 bonding, 1 non-bonding, it's going to be trigonal pyramidal. We have XeF2, which is going to look like this. So when we get done putting the lone pairs on the outside fluorines, we have 6 electrons left, and so those all go on to xenon. So the electron domain geometry, we're going to have 5 domains around a xenon, so that's going to be trigonal bipyramidal. And then the molecular geometry, because we have 2 bonding and 3 non-bonding, that's going to give us linear. Okay, then we have BrO2 negative, which looks like this. And then when we get done putting the electrons on the outside oxygens. We have 4 electrons left over, so they go on bromine, the central atom, and we have an overall negative charge. So we need to show that as well. So here, our electron domain geometry, we have 1, 2, 3, 4 domains. So that's going to be tetrahedral. And then the molecular geometry, we have 2 bonding and 2 non-bonding. So that's going to be bent. Okay, so that was number 12. Number 13, we had the bond angles that we were looking at. So to figure out the bond angles, we just need to figure out what the central atom is and then how many domains around the central atom, and then we can figure out the bond angles. So for this one, oxygen is the central atom here because we're looking at the bond angle between hydrogen and chlorine. So we want to look and see what's on oxygen. So we have a total of 1, 2, 3, 4 domains on oxygen, which is tetrahedral. And so that's going to be our 109.5 bond angle. Okay, and then the same thing over here. So on this one, we're looking at the bond angle between the oxygens. So that means we've got to look at our central atom here, which is chlorine, to see what the bond angle is going to be. So we've got 1, 2, 3, 4 domains around chlorine. So we're going to get the same 109.5. Okay, on carbon here, we want to know what the bond angle is between the hydrogens. So carbon is our central atom. So we've got 1, 2, 3, 4 domains around carbon. So again, we get that 109.5. And then oxygen, we're looking at the bond angle between hydrogen and carbon. So we want to see what's on oxygen. So we've got 1, 2, 3, 4 domains around oxygen. So same thing, 109.5. Okay, this one's different. Okay, so this one we're looking at the bond angle between hydrogen and this carbon. So this is the carbon that is the central atom, and we only have 2 domains here. So 2 domains means linear, and it has a bond angle of 180. Okay, on this one, we're looking at the bond angle between hydrogen and oxygen. So carbon is our central atom here. So we've got 1, 2, 3 domains around carbon. So that's going to be trigonal planar, which is 120. And then on this one, we're looking at the bond angle between the carbons, the 2 carbons. So oxygen is our central atom. So we've got 1, 2, 3, 4. So that's tetrahedral. So that's that 109.5 again. Same thing here. We're looking at the bond angle between the hydrogens. So carbon is our central atom. And we've got 1, 2, 3, 4 domains, and so it's going to be 109.5. Okay, now let's do number 14. Okay, 14 says, how many non-bonding electron pairs are there in each of the following molecules? So the first one we have is CH3, and it says 2s. So we have to draw that to figure out how many non-bonding pairs we have. So I'm not going to ask you to draw anything like this on the test, so don't worry about it. But to correctly draw the Lewis dot structure here, we would have 2 lone pairs on S. Okay, so that would be the answer. We have 2 lone pairs in this molecule. And it's not just on the central atom, it's on the whole molecule for this question. Okay, for B, we have HCN. So this molecule is going to look like this. Draw the Lewis dot structure. So I have 2 lone pairs for B. And then C is H2C2. Okay, so the carbons are going to be attached to each other, then 2 hydrogens on the carbons. And once you move all your electrons around, you're going to get a triple bond. So there are no lone pairs on this one, so 0. And then the last one, D, we have CHF3, which looks like this. CH3F. I think I said that wrong. CH3F. So we have 3 lone pairs in this molecule. Okay, now number 15. Okay. So number 15, we are predicting whether the molecule is polar or nonpolar. So in order to do that, we need to draw the Lewis dot structure to figure that out. So pretty much everything after Lewis dot structures, you have to draw the Lewis dot structure to figure out whatever the question is asking. So be sure you're doing that on the test. Let me get to the right spot here, sorry. I'm not finding it, it's because I'm looking at the wrong thing. Okay. Okay, fine. Okay, on this one, CCl4, so it looks like this. We have C, and then the 4 chlorines around it, and then the lone pairs on the chlorines, and then all the electrons are used up, so there are no lone pairs on carbon. So that's what it would look like. So chlorine is more electronegative, so the dipoles are all going in the direction of chlorine, so they're being canceled out. So this would be nonpolar. Okay, then we have B, which is NH3. Okay, so this molecule is going to look like this. Okay, NH3. So this lone pair is actually really big, and it shifts these bond angles down to where it would look something like this. And because nitrogen is more electronegative than all the hydrogens, then the dipole goes up towards nitrogen. So because they're not canceling each other out, this molecule would be polar. Okay, and then C, we have SF4. Okay, and then we have the lone pairs on fluorine. And then after we get done putting the lone pairs on fluorine, we'll have 2 left over that go on sulfur. Okay, so that lone pair, again, is really big. And since we have 1, 2, 3, 4, 5 domains, we have trigonal bipyramidal. So that lone pair is going to be in the equatorial position with 2 of the fluorines, and it's going to push the 2 fluorines basically to one side of the sulfur. So the dipoles aren't going to be canceled out. So something like, let's see if I can draw this. So we have the fluorines in the axial position, and then we would have the fluorines over here on this side with the lone pair over here. So we'd have the dipole going in that direction. So this one would be polar. Okay, now last one we have D. XeF4. So in this one, we have 4 fluorines around Xe. And we're going to get the lone pairs around fluorine, and then after we get done putting the lone pairs on, we're going to have 2 left over, 2 electrons, I'm sorry, not 2 electrons. We're going to have 4 electrons left over to make 2 lone pairs on the central atom. Okay. So this one is square planar. So for this one, we have xenon, and then the lone pairs are actually in the axial position. And then we would have our fluorines in the equatorial position. So the dipoles are all going out towards fluorine. So there's going to be one going that way, that way. So they end up canceling each other because these lone pairs aren't in the way because they're in the axial position. So this one's going to be nonpolar. Okay, and I believe that is it for chapter 8.